An introduction to precipitation reactions through video because I won't be in class. For C block at least, and B block you can watch this as well. We talked about classifying reactions by what the atoms are doing, and that was single replacement, double replacement, synthesis, decomposition. There's another way to classify, and that's by the chemistry of what's happening. We're going to be looking at states of matter and the types of compounds and elements that are reacting. So here's a layout of what we're going to be looking at: precipitation, acid-base, gas evolution, and redox. And we are going to talk about precipitation. So I'm going to be switching between, this is the slideshow, and then I'm going to go back into OneNote if we have to do any work. So precipitation reactions are going to be a form of double replacement reactions. Okay, so in our classifications, for the most part, we can label them two different ways. So all precipitation reactions for us are going to be double replacement, but not every single double replacement reaction is going to be precipitation. And our definition of the precipitation reaction is when two aqueous solutions are mixed and one or more solids are formed as products. So two compounds that are AQs behind them on the reactant side, and then at least one solid is formed on the product. And we kind of alluded to this the other day in class. How are we going to know what the state of matter is? And it has something to do with something called the solubility rules. So when you're looking here, you can click on this link and it'll take you to a very, what I think is a funny video of a guy who wrote a song for solubility rules, and it just gets stuck in my head. But what the rules themselves are going to be laid out in some type of table form. I thought I put something different on there, but I didn't, sorry. So this is one form of the solubility rules. And basically, we're going to have to consult this. Let me actually go to the OneNote and get it, because this is what you're going to be seeing on your sheets during class. And it's the rules that kind of govern whether or not it's going to be aqueous or solid. And so solubility means it dissolves in water. Right? If something is soluble, it dissolves in water. If something is insoluble, it does not. So soluble compounds get aqueous as their state of matter. Insoluble, if I could even spell sol. And insoluble compounds do not dissolve, and ionic compounds that do not dissolve, they stay as solids. The way that you read these rules is they are a hierarchy, right? So we consult the first rule and then we work down. So if you're looking at your compound and it has an alkali metal or ammonium as the cation, then that compound is soluble, meaning it's going to be aqueous, and there are no exceptions to that rule. So that's why I say all alkali metals and ammonium salts. And salt is another word for ionic compound. And then we can go down. If you don't have an alkali metal or ammonium, then we consult the next rule and see if that applies to our compound. All nitrates, chlorates, and perchlorates are soluble. Again, no exceptions, and then we keep going. All silver, lead 2, and mercury 1 compounds are insoluble, no exceptions. All chlorides, bromides, and iodines are soluble, no exception. But here's the thing, like, what if we had a silver chloride compound? So we would treat this as, or we would look at these rules from top to bottom, because if I were to look at rule 4, this would make me think that, oh, this is a chloride, oh, it's soluble, it's AQ. But if you look at the rule above it, right, it says all silver, leads, and mercuries are insoluble. So rule 3 of our solubility rules trumps rule 4. So yes, this is a chloride, but more importantly, it's a silver compound, so it is not aqueous, it would be solid. So that's why you have to read from the top of the list to the bottom. And let's get some practice. The solubility rules I'll keep here. And we want to know whether the following compounds are soluble or insoluble, okay? So our first one is sodium fluoride, NaF. I'm going to keep the compound here so that we can see what we're looking at. So we start from the top, and if that rule applies to your compound, then you are done and you can get your information based on that rule. If it's not, if your compound doesn't contain anything in that rule, then you move to the next rule and you keep going until you hit that compound. Okay, so it says all alkali metals and ammonium salts are soluble. And that's referring to the cation. And here's where we understand that sodium is an alkali metal. So this is the rule that applies to us. All alkali metals are soluble. Our idea of soluble means it dissolves in water. So NaF gets an AQ. Now, if we look at silver nitrate, you might go, oh, I remember all silvers are solid, but we need to go through our rules. Okay, first rule does not apply because it's not an alkali metal or ammonium, but our second rule, it says all nitrates, chlorates and perchlorates. Well, this is a nitrate. Okay, so more importantly than the fact that it has silver, it has a nitrate in the compound, and it's telling us that it is soluble. So even though it's silver, that's not the important part, it's the nitrate. Okay, then we come here, we have PbI3. Not an alkali metal or ammonium. Move to the next. We do not have nitrate, chlorate, or perchlorate as the anion. That is, it's not silver, it's not mercury. This is also not lead 2. This is lead 3 iodine. So rule 3 does not apply to this compound. So I hit rule 4 and says all chlorides, bromides, and iodides are soluble. So we go through all of our rules until we get to the rule that applies. So it's important to know what ion you're working with as well. AgCl was our example, and we said that, right, rule 1 and 2 do not apply, so we're going to look at rule 3, which says all silver, lead 2, and mercury 1 salts are insoluble. SrO2, no, sorry, SrSO4, sorry about that. Okay, not an alkali metal, so strontium is in the second column. That's alkaline earth, so we need to understand our families. That's not nitrate, chlorate, or perchlorate. We don't have silver, lead, or mercury. Okay, this also is not a chloride, bromide, or iodide, so we're down for here all carbonates, oxides, sulfides, hydroxides, phosphates, chromates, and sulfites. This is not sulfite, this is the sulfate ion, so we actually get ourselves down to rule 6. It says all sulfates are soluble, and if we look to the right, there is actually an exception to that rule. Calcium sulfate, strontium sulfate, and barium sulfate are insoluble. So most sulfates are going to be soluble except for these 3, and we happen to have one of those exceptions, strontium sulfate. So we're going to read this as strontium sulfate is insoluble, and insoluble means that it is a solid. Okay, so that's how we use our solubility rules. I'm going to leave these last 2 for you to do, and then you can come back to OneNote and check your answers based on your solubility rules. But again, we're using these solubility rules because we said if an ionic compound is present, or if water is present when there's an ionic compound around. And by definition, we have aqueous solutions. So that means that there's water around. So we can't just say that they're solid, we have to consult the solubility rules. Some of them may be solid, other of them won't be. You can go back to the slideshow. Okay. We're going to work on our predicting products here. And what we're going to do is we're going to write balanced reactions for the following solutions when they are mixed. And should be going back here so we can do some work. Okay, write balanced reactions for the following. So potassium sulfate reacting with barium nitrate. So here we're given the reactants, and we're also given the state of matter of the reactants, because by definition, these reactions are when 2 aqueous solutions are mixed. Okay, so we're going to say that potassium sulfate, K2SO4, because it has to be neutral, is going to react with barium nitrate. And again, these are both aqueous because they're solutions that are mixing. And what we need to do is, in order to predict the product, we have to recognize this as a double replacement reaction so that we can help form our new compounds. And once we have our new compounds, we can try to figure out the states of matter. So our cations are going to switch place. So the potassium is now going to go hang out with nitrate, and the barium is going to go hang out with the sulfate. So before we left for break, when we were writing reactions, we have to make sure we have neutral compounds. So when potassium goes with nitrate, I'm not looking at the fact that there's two potassiums. I needed two so that we had a neutral compound with sulfate. What I'm looking at is that we have potassium making a compound with nitrate. Okay, so our new product between those two is KNO3, and you might be going, but there's two potassiums on the left side. Remember, neutral products first, then we can balance, okay? So we have that. Potassium nitrate is one new compound, and then the next compound, we just said potassium with nitrate, barium is going to go with sulfate, and barium is +2, sulfate is -2, so we get BaSO4. Now, we need to, part of predicting our products is the prediction of the state of matter, because we need to see if we get a formation of a solid. So let's go back to our solubility rules. Our first compound is potassium nitrate. Potassium is an alkali metal, and all alkali metals are soluble, so this first one is aqueous. And then we go to barium sulfate. Again, barium is not an alkali metal. The first rule does not apply. All of the rules do not apply until we get to the sulfates. And it says all sulfates are soluble. We need to read the exceptions. It says calcium sulfate, strontium sulfate, and barium sulfate are insoluble. Those are exceptions to the rule, so we get an S there. So we just predicted our products. Now we need to balance our reaction. Okay, once we have our products predicted, we can go ahead and get those potassiums and nitrates balanced. So I have two potassiums on the left side, two potassiums on the right side, and that 2 now just gave us 2 nitrates, and I have 2 nitrates on the left side. Here's our balanced equation. Okay, so when you mix potassium sulfate and barium nitrate, you're going to see the formation of a solid, and based on the ions that are in there, the only solid that can form is barium sulfate. Okay. Let's do one more for lithium chloride and silver acetate, and then I'll leave the last one for you guys to come back and check. So we have lithium chloride. Again, we need neutral compounds, lithium +1, chloride -1. I know that it's aqueous because they told us that these are solutions, and that is reacting with silver acetate. Acetate ion is on your sheet, C2H3O2. It is a polyatomic ion, it's -1. So we have silver C2H3O2, and that's aqueous. Again, these are solutions. They tell us they are solutions, but you can check the solubility rules. Both of these would come out to be aqueous. And when we predict our products, the cations switch places. So silver +1 going with chloride -1, AgCl. Remind myself that I need states of matter. And then lithium +1, lithium and acetate +1 -1, so LiC2H3O2, and that's state of matter. So we'll go up, check the solubility rules for AgCl. Remember, silver, lead 2, and mercuries are all insoluble, so this is going to be a solid. And lithium carbonate, or I keep saying carbonate, lithium acetate, all alkali metals, which lithium is, are soluble with no exception, so this is aqueous. Once we get that state of matter, go ahead and check and see if it's balanced, and if not, go ahead and balance it. Since these are all +1 -1 ratios, or charges, we see that we get a 1-to-1 ratio for everything. But once you have different charges between compounds, you're going to see that you need to use coefficients to balance. But this reaction is now complete. So you can try that third one, and you can come back here and check